Hello everyone, welcome to Algo-holic, the place where you learn not just the solutions but the thought process behind solving problems. Today we're solving the problem, best time to buy and sell stock. We're given an array of prices where each price is the price of a given stock on ith day. We want to maximize profit by choosing a single day to buy one stock and choosing a different day to sell that stock in the future. We're supposed to return the maximum profit we can achieve from this transaction. So basically buy low and sell high. Let's look at an example where we can get a profit of 5 by buying on this day and selling on this day. Another example here, all the prices are in decreasing order, so the stock is going down. And no matter when we buy the stock, we won't be able to make a profit from this. So what is the brute force solution to this? Well, we have two unknowns, the day we buy the stock and the day we sell the stock. So we can just have two loops trying to find out what those unknowns are. So let's say we have 7, 1, 5, 2, and 3. So we have B, which is going to be the day we buy the stock, and S, which is going to be the day we sell the stock, and a variable P trying to find out the current profit. So we buy on this day, we try to sell on this day. It's not going to be a profit, so we move on. Here again, not a profit. Here again, not a profit. Here again, not a profit. So we increment B. So B is at 1 now. So we try to find out if there's a profit when we sell it as 5. Yes, there is a profit. So P becomes 4. Then we move over here. There is still a profit, but since the profit is not more than 4, we move on. Again, the same thing applies. The profit exists, but it's not more than 4, so we move on. So B comes over here. We buy it over here. We try to sell it over here. It's not a profit. Try to sell it over here. It's not a profit. So we buy again at 2. We try to sell it at 3. It's not a profit, so we exit the loop. So the highest profit that we got was 4 when we buy it at 1 and we sell it at 5. So this is the brute force solution. So how do you arrive at the most optimal solution? One hurdle I've seen people face is that they don't translate the problem into a much simpler problem which would help them visualize better. Since we just have to make one transaction, what the question is really asking of us is to find two numbers where the difference between the numbers is the largest. So let's say we have 7, 2, 5, 6, 1, 2, and 6 again. We need to find two values B and S. And we also need to note that the buying price, which is the first price, is going to be less than the second price. Because if it were the other way around, we would end up with the largest loss instead of the largest profit. So that's one condition we need to be aware of. We also have profit, which is going to be 0. And we have I, which is going to loop through the array. Let's say that we buy the stock at the first available price. So we're buying the stock at $7. In what scenario would we like to change this particular decision? We would like to change this when we find a better buying price for us. So a price which is lower than 7. Let's see if we find that. I moves to the next pointer. Now we found a value which is less than 7. So we would like to buy it at 2 instead of buying it at 7. So we change the value of B. We move I. Now we found a value which is more than B. Now it doesn't make sense for us to move the value of B because we are paying 2 currently. Why would we want to pay 5? So we assign S to this. So we are buying at 2 and selling at 5. The whole point of this is to find two values such that the first value is less than the second value. And this is one of those valid scenarios. This might not be the scenario in which we find the largest difference between two numbers, but it is still a valid scenario. So what is the profit that we get from this? The difference, it is going to be 3. We move I again. Now we found a value which is more than the current value of S. So why would we sell the stock at 5 when we can sell the stock at 6? So we move the value of S. Now we also change profit because the previous profit was 5 minus 2. Now it's 6 minus 2. So the profit becomes 4. We move I. Now we found a value which is less than B. So what do we do now? We found a better buying price. So we move the value of B. The profit is still going to be 4, by the way, but yeah. Now let's move I again. Now we found a valid scenario where it allows us to make a profit. Because if we move S now, the profit is going to be 2 minus 1, which is going to be 1. What this is trying to tell us is that this is another way to make a profit. This might not be the best way because the best way is still 6 minus 2, which we got from the previous transaction, but this is still a valid way. So B is going to be here and S is going to be here, but we don't increment the profit because we only increment the profit when we get a scenario which is more than the current value of 4. That is the only scenario in which we increment the value of profit. Now let's increment I again. the last case where I is pointing at 6. Now, since the value of I is more than the S value, which is 2 currently, we move S as well. Now, what is the profit that we get? We are looking at 6 minus 1, which is a profit of 5, which is the best case for us. So the reason this works is that B is always going to be before S because we obviously need to buy the stock before we sell the stock. And as long as we only change the value of P when the current profit scenario is more than the profit that we encountered from a different transaction, this is always going to work. Now, what is the time complexity of this? We are just looping through the array once. So the time complexity is going to be big of n, and the space complexity is going to be constant because we're not taking any extra space except the space needed for 2 or 3 variables. Let's quickly code up the brute force solution. The outer loop is for the buying date. The inner loop is for the selling date. We also need to make sure that we can only sell after we buy, so b plus 1. And here we calculate the profit and we take the max. We can also simplify this by just doing this. So yeah, that's about it. Yep, this works. Let's code up the optimal solution. Profit set to 0. The buy price is going to be set to the first value in the array. Here we assumed that we're going to be buying on the first day. So this is the code equivalent of that. We loop through the array but leave the 0th index. Now there are two major scenarios that we need to account for. One is the movement of the buy price, buy value, and second is the change of the profit. We can also add a third variable to account for the selling price, but since we saw earlier that this can be streamlined using profit, we don't need a third variable. So if the current value that we encountered is less than what we previously paid to buy the product or the stock, we change the buy price. Else we calculate the profit. So profit is max of the existing profit up until now and the profit from the current transaction, which is price is I minus what we paid for the stock. We just return the profit. Yep, works. This is the most optimal solution. C++ code looks pretty much the same where we have the buy price set to the first value in the array. We loop through the array. We check if the current value is less than what we paid for and the calculation of profit. Java code again looks the same. The only difference is the way we get the length of the array and we call a class in Java to get the max of 2 values. So that's all for today. I hope you found this video helpful. Your feedback helps me make better content. So please share your thoughts in the comments below. I'll see you in the next one.